In this video, we will discuss two important theorems that describe how lines and segments intersect circles. I strongly advise that you copy the two theorems on your notebook. The first one is called tangent line to circle theorem. It says that a line is tangent to a circle if and only if the line is perpendicular to a radius at its endpoint. So there are three words that we have to focus on this theorem. The first one is tangent. By definition, we know that a line is tangent if it touches the circle at only one point. So in this case, the point of tangency is point P. Perpendicular. Perpendicular means they form a 90-degree angle. So that means this tangent line makes a 90-degree angle with the radius drawn from the center. So in this figure, line M, which contains P, is tangent to circle Q if and only if it makes a 90-degree angle with segment QP. So why is this important and how can we use this for computations? Let's look at one example. In this example, we're given a circle with an unknown radius. The extension outside the circles are 50 and 80 respectively. So since we know that a line that is tangent to a circle makes a perpendicular or 90-degree angle with a radius, we can conclude that angle B is a right angle. If angle B is a right angle, then we can conclude that triangle ABC is a right triangle. If it is a right triangle, we can use a Pythagorean theorem to solve for the missing dimensions. So since the radius is r, we can let that our a squared, and then 80 will be our b squared, and our c squared will be the combination of the red and the blue segment. So substituting into the Pythagorean theorem, we have r squared plus 80 squared is equal to r plus 50 quantity squared. We bring this down on the right hand side, and then if you look at this square of a binomial, you have to multiply r plus 50 by itself. In Algebra 1, we learned about the box method or the double distributive method, so you can use any of those methods to find the product when you multiply r plus 50 by itself. It will turn out to be r squared plus 100r plus 2500 is equal to r squared plus 6400. By combining like terms, we can subtract r squared from both sides and we will be left with 100r plus 2500 is equal to 6400. We can subtract 2500 from both sides and we will get 100r is equal to 3900. Dividing both sides by 100, we will get r is equal to 39. The next theorem is called external tangent congruence theorem. It means that tangent segments from a common external point are congruent. If you look at this figure, the two tangent segments being referred to are segments SR and ST. They come from a common external point, which is point S. According to this theorem, segment SR is congruent to segment ST. So let me emphasize that this only happens when both segments are tangent to the circle. Let's look at another example to show how to use this theorem. In this figure, RS is tangent to circle C at point S, while RT is tangent to circle C at point T. Find the value of X. According to this theorem, two segments that are tangent to the same circle have equal measures. So we set RS is equal to RT, and by substitution, 28 is equal to 3x plus 4. If we solve for x, we subtract 4 from both sides, and then we divide both sides by 3. So the final answer will be x is equal to 8.